Assalamu alaikum. So in this video, we'll solve some essay exercises from MATH1 final exam of last year, 2021. This exam will help students from College of Engineering and College Computer Science to prepare their final exam. In this exam, there were 4 essay exercises, 6 points, 4 points, 6 points, 4 points. And in this video, we'll give the solution of exercise 1, solving equations and inequalities, chapter 2. And in other videos, we'll see some of the other exercises. Okay, let's start from with the first exercise. So first question, equation, radical type. This is easy. So the radical is isolated. So here, since the radical is isolated, نحاله في one side, radical, we can directly square both sides. Square of the root cancels. 4x plus 13 equals, and here be careful, as I said in previous videos, do not distribute the power with respect to the over the addition. So here we have a formula, first square 2 times the first times the second plus the second square. Be careful about that. So we get an equation of order 2. So the highest degree of the variable x is square. So we have to solve a quadratic equation. To solve a quadratic equation, we write it in standard form. We move x squared plus 4x plus 4, and we move this term to the other side, minus 4x minus 13. What we get, x squared, here 4x minus 4x, we simplify, 4x minus 13 minus 9. So here we have the choice, we can factor, so x minus 3 times x plus 3. So we have 2 options, x equals 3 or x equals minus 3. But we are not done yet to find the solution set. Still unknown. Since it's a radical type equation, we have to check. There might be extraneous solution. So for x equals 3, we replace in the original equation. We get root 12 plus 13, 25 equals 5. This is correct. For x equals negative 3, we get root minus 12 plus 13, 1 equals minus 3 plus 2, minus 1. And this is false. So this is called extraneous solution. So finally, the solution set S is, we have only one solution, S equals 3. Now question B, in this first exercise, final exam, we have an inequality, a rational inequality. Rational inequality, section 2.5. So here also, be careful. Don't multiply by x plus 6. Okay. So here, to solve this inequality, it is already in a single inequality. Single inequality, so it's ready. So here the question is to find the zeros or roots of the numerator when the numerator equals 0 means x equals 1, and roots of the denominator equals 0 when x equals -6. Then we have to draw the real line. So in the real line, 1, the numerator, it can be 0, and -6, the denominator, is a whole because no division by 0. We take test points. For example, 0 here. If we replace by 0, we get -1/6. For x equals 0 is negative. So here minus. We can take 2 مثلا. For x equals 2, we'll have 1/8. It's positive. So here plus. Can take here, for example, -10. So -11 over -4. 11/4. This is positive. So what is the solution set here for this inequality? We want it greater than or equal 0. So we take this part and we take this part, -empty, -6, 1 to empty. -6, it's the root of the denominator. We have always to open. 1, the root of the numerator, it's greater than or equal. So we close and we have union. So here I will write, to be clear, -empty, -6, open, union, 1 to empty, close. This is the solution set of this inequality. Third and last question of this first exercise, 2 marks. We have 2 linear inequalities. So this is this section 2.4, linear inequalities with and. So here we solve each of the inequalities. So the first one, linear inequality, we collect x's in one side and constant in the other side. So x less than or equal 3. So this gives us -empty, closed. The second inequality, x plus 1 less than 4x minus 5. We collect them, 1 plus 5, 4x minus x, 3x greater than 6. We divide by 3 in a new line, be careful. So 3 is positive. We didn't change the direction. So x greater than 2. So this is 2 open infinity. And we have, be careful, and. And means that the solution is the intersection of these 2 intervals. So what is the intersection? So we have the first one, 3 to -empty. The second one, 2 open, 2 empty. So where we have both colors in this area, so the solution is 2 open, 3 closed, and we are